Going on, everybody? Hope everything's going well. So, in the previous lecture, provided in the description of this video, we discussed various topics such as, we'll take a look at that, such as the principle of equivalence and also the curvature of light within a gravitational field. So, both are pretty interesting topics. Definitely take a look at the previous video, which we have linked in the description regarding those two topics. So this time, we're actually going to derive the equations of Einstein's field theory shown on the screen here. So, you may notice that only one equation is displayed on the screen. However, this is not the case. You will also notice that there are some indices, which are mu and nu, which are Greek letters, which exist in several places throughout the equations on the screen. So mu and nu represent the dimensions of space-time, including naught, 1, 2, and 3. Naught represents time, 1 represents the x-axis, 2 represents the y-axis, and 3 represents the z-axis. Thus, mu and nu can take on 4 values, or up to 11 values, depending on how many dimensions you are working with. The combination of mu and nu represent between 16 and 121 variations or versions of these equations. So in the simplest case, mu and nu combined would create 16 versions of these equations from three-dimensional space and time, or 4D space and time. So you may think, therefore, there are 16 equations in four-dimensional space-time. In fact, 6 of them reduce, thus it reduces to 10 equations. So thus, on the screen now, you're actually looking at 10 equations of Einstein's field theory. That's very interesting. So now you may be wondering what all of these hieroglyphics mean. Well, you'll be relieved to know that some of them you may already know. So you will know what 1/2 is, and you will know what 8 is. You'll also know what pi is, and you'll also know what g is. G is the good old gravitational constant, and you will also know what c is. C is the speed of light. Thus, there are only a few things you may not know. First, we have this interesting term here, which is r mu nu, which is known as the Ricci curvature tensor. We will derive that shortly. And then, in 2 places in this equation, you have g of mu nu, so here and here. This is known as the metric tensor. We will derive that later on as well. You will also notice that we have a value of r that has no indices, and this is known as the curvature scalar. We will show what that is in a future lecture as well. And we also have capital lambda here. So capital lambda turns out to be the cosmological constant. We will explain the reason for that as well, and the reason why it is in this equation. And then finally, we have over here on the right-hand side, we have T of mu nu. This is the stress energy momentum tensor. We will try or attempt to explain what that is as well. It's a very complex term there. So the whole point of this equation is that it balances 2 aspects. And we'll take a look at that. So everything on the left-hand side here of the equal sign represents the curvature of space-time. Everything on the right-hand side represents mass and energy. Some physicists have sometimes referred to what Einstein had stated about these field equations is that mass communicates, with emphasis on communicates, to space-time on how to curve. And curved space-time communicates to mass on how and where to move. So you can definitely see the interesting implications of this here. So definitely some interesting implications. You could see some of the aspects from Stranger Things, the TV show, and the reality of the Montauk Project and the Philadelphia experiment relied on these equations. So basically, in the next video, we are going to derive what is known as the metric tensor. So this right here, these two values, as we stated before, g, mu, nu, this is what is known as the metric tensor. Alright guys, thank you all for joining me for this short video. All of your support is much appreciated. Once again, the music provided within this video is brought to you by Guitars and Ghosts. Definitely go check out his YouTube page and show him some love. Also, if you're interested in more videos like this, please consider subscribing to our YouTube channel, smash that like button, and leave a comment in the video if you enjoyed it. Also, if you have the means to donate to our channel, please do so at the PayPal link provided within the description of this video. If you would like to see live drone flights, weather reports, and or other various materials, please consider following us on Facebook and the link in the description as well. Again, we thank you for all of your support. Remember, always be on the lookout. Our world is not what you think.